Once again, thank you very much, Alan Duggan, for giving us your time today. We're going to be talking about standby power plant, and we're here at the Waikato Hospital. So let's start at the beginning. What would be the overall demand of standby power aside, the overall demand of Waikato Hospital in terms of
probably gets up to close to 4 megs.
So 4 MVA or 4 megawatts, whatever.
Yeah.
And if you were to take a proportion of that as your essential, in other words, it cannot be interrupted, what would you say that is?
Well, I think we'd probably go for about 60%.
60%?
Yeah.
Wow. So
that's within 30 seconds.
Oh, okay.
Yeah. Our standby plant's up and running within 30 seconds, yeah.
And that 30 seconds standby power is delivered by gensets largely?
Yeah, four gensets.
So we'll start at the beginning here then, and you've got your fuel supply.
Yep.
How much? This is for one generator?
No, that's for 4 generators.
That's the whole lot?
That's the whole lot of it.
Okay.
20,000 litres.
20,000 litres of diesel? $20,000 litres, and here we've got indication as to its status.
Yep.
Full tanks?
Yeah. Full tank, overfull, and then graduated. And when lights just come on now, just slightly below full.
And all 4 of your generators are in the one building, is that right?
Yes. In one building, divided in 2. There's 2 in one fire cell and 2 in another.
Oh, nice. Let's have a look.
We generate 11 kV here, or we generate at 400 and transform up to 11 kV into our ring.
Oh, I see.
Yeah, we don't feed 400 volts to a building. We feed back into our 11 kV ring.
Right. So all your transformers are your own?
No, transformers are owned by Well.
Okay.
Yeah.
11.
This is our 11 kV switchgear. The 2 extreme left and right go out to our ring, 11 kV ring, which comes around the side, and the middle ones are fed from the transformers, which generate up from we generate at 400, generate and transform up to 11 kV. This is basically
A SCADA system there.
yeah.
And there's your 4 plants on the right.
That's our 4 plants on there, right? Those are our 2 injection points. This is the schematic for our ring, and those are our 2 incomers from Well. Hasn't quite been handed over to us yet, so we're still in the commissioning stage of it.
Yeah, nice.
So if we lose, the hospital has a 11 kV ring going around 16, or will be soon, 16 substations, and we have 2 injection ports from Well. They're both alive, but only one's switched in at any one time. So if we lose that one, we automatically change over to the other feeder. If that's not available, the generators start.
Right. So you've got your generators are plan C, so to speak.
Yeah.
Plan B is the other main utility feed.
Well, yes. Yep.
Mm.
And then the first 2 substations from the well input, that's where we inject our 11 kV. I can show you that on the drawing. That's a well switching station on site. They have 2 feeders coming in from, where are they? Those 2 there, they come from Common Drive substation. We've got 2 from Common Drive substation. We've obviously got 2 from Latham Court, and we have got another one comes in here from Peacock's Road. So they've got 5 supplies into there, so it's pretty well covered.
Yeah.
Then we have 2 feeders coming out here. One comes into here, one comes into there, and that's in our laundry sub. And then we have 2 feeders going out here, going right round the site. Then we have this is our generator. And we have got that there feeds in to there, and that one there feeds in, that one feeds into there, and those are the 2 switches there. quite a complicated setup. That's before you even start about worrying about when the generators start.
Yeah. So
Yeah.
none of this, of course, controls the generators? Is any of this equipment in this room actually connected to the... That's all in a separate area?
That's all 11 kV. The generator control is all from that cabinet there.
Oh, yeah. Okay.
And from another similar cabinet down in the laundry where the incoming.
That's really interesting. So this box here is basically controlling the load shedding. Should the worst thing happen.
Yep.
And your substations throughout your ring circuit, 16 or 15 of them.
Yeah, 16 substations feed what we call a main switchboard.
Yep.
And those main switchboards are divided into essential and non-essential, and that controls the contactor in there. And also it prioritises the substations, all our substations, depending on the level of medical care, and prioritise 1 to 4. Priority 1 comes in first, through to 4, but all that happens within 30 seconds of losing power.
Wow.
Yeah, as well as that, the priority goes back the other way should we have a problem and start losing generators for any reason. Priority 4 drop off first. So then if we get down to 2 generators, they're feeding the priority 1 areas.
So what would be the difference between a priority 1 and, say, a priority 4? Would it be the type of patient care?
Yeah, priority 4, no patient care, it's just office.
Okay.
Office blocks and sort of day clinics, things like that. Priority 1 is your ED department, theatres, HDU, CCU, things like that. Cardiac investigation areas.
Wow.
Open this up.
Some serious networking going on in there.
Yeah. This hasn't been handed over to us yet, so I could.
So, what are we looking at here per power plant? We've got it's a 400 volt generator,
Yep.
capable of 1600 amps at 1500 RPM. So we're talking about 1.1 MVA
Yeah.
per alternator,
Yeah.
and you got 4 of them.
Got 4 of them here.
All right, and we've got what have we got here? We've got V16 diesels,
Yep.
turbocharged. And what's the starting method? Are these electric start?
Electric start. Yep.
Off a 24 volt?
Off 24 volt batteries. Yep.
So each one has a bank of batteries.
Yep. Dual battery chargers on them.
And there's your starter motor. And so all this hydraulic stuff that we're seeing here, what have we got going on here? Are these fuel pumps?
Fuel pumps, yes.
Right, so you've got an incoming fuel line.
Yep.
Yeah, lots of filtering. And
There's a tank in there's a day tank in the base of the generator.
ah, right, that's why I saw a tank inlet on the other side there.
Yeah, and this is just drawing it from the main tank into here, and that's a 24 volt DC fuel pump off the batteries.
And some pretty serious looking cooling going on there. And extraction. And so all of this is this all fed back to a PLC as well in your SCADA system?
Yep.
So you can tell what's going on when it's running and when it's not running?
Yes.
So how often would you come down here and give these things a run?
At the moment, because it hasn't handed over to us, so that's still in the planning stage, but they will run once a month. And it'll be automatic. There's a couple of teething problems we've got to sort out, but what will happen is that you just go onto the screen there, click on the button, and these will all just fire up. They will sync to the mains, and close, but it's limited to, we will only generate up to 80% of what we draw from well. So we don't cogen. We don't inject back into wells network.
Oh, I see. So you'd just be reducing your demand coming
we're just
in.
reducing the demand coming in.
So you're actually putting them under load.
Yes. Oh, yes. Yep.
All right.
And then once a year, we will be doing a black start.
So you drop the mains,
Drop the mains.
drop the supply.
Yep.
Boom.
Drop the supply and let them go.
Obviously, surgery's planned around that event.
Well, yes. It's quite difficult to organise, but that's once we've done a few tests and the medical people have faith that they work. That's just what we've got to build up, and we've done a lot towards that now, and there's a lot of faith in them compared to the old ones.
Yeah.
Which we had a few problems with. That's why we've got these elements in the jacket heaters. There's two jacket heaters here.
Oh, I see. Keeping them warm.
Just keeping them warm, so they're up to temperature at all times. The whole block's up to. That's probably the ticking is just that. Yeah,
Oh, I see.
40 degrees at all times.
So it's just keeping the oil flowing, it's just
Engine temperature.
circulating.
40 degrees.
Ready to roll.
Ready to roll, yeah.
So what can you tell me about the UPS side of things? Because certain loads and certain circuits are connected to your blue power points,
That's correct.
which are UPS backed up,
Yep.
and are they direct on UPSs? In other words, everything's going through the UPSs the whole time.
Going through the UPS the whole time, so that's seamless.
Right.
We have major UPSs on our information services computers, our mainframes. We've got two on there. We've got another computer on all the blue power points in our neonatal unit, and we've got another UPS on all the blue power points in the ED department. The new builds having UPSs on power points in the CCU, HDU area. We've also got two massive UPSs on our catheter lab, where we're putting catheters into people's brains and catheters into people's hearts.
Yeah.
All those machines now backed up by UPS. So that should there be a failure, all the screens stay alive, so surgeons are quite comfortable they can still carry on seeing what's going on.
Oh, cool. Too much more of your time. The only other thing I wanted to touch on was emergency lighting.
Yeah.
Because that's sort of separate, isn't it? You have to be able to provide enough illumination to certain levels in certain areas for a certain amount of time.
Yes.
What's the main sort of emergency lighting system that you use here?
Well, it's all been changed over. There's a new system now. It's just some of it's LED, some of it's those little halogen 24-volt standalone fittings.
Oh, with
round ones.
the two little flood things with the...
No, they're just recessed into the ceiling with a little. Yeah. And that's all backed up with an intelligent system. It's tested automatically, and if any of the lights don't go, that comes back and feeds back onto our computer system. It tells you, they're all ID, it tells you when the bulbs are blown. So we're swinging over to that as well.
So this is a bit more advanced than the old NiCad batteries and the light fitting mounted to the wall?
Yeah. Yes.
And how long can they run for?
They probably run for depending on the evacuation policy of the building, it'll be somewhere between an hour and a half and 2 hours. Right,
and that's related to fire code too?
Yeah, that's related to the fire code, yeah. Anything medical is backed up with the generators. Like lighting for medical reasons, medical procedures.
Well, once again, Alan, thank you very much on behalf of Wintec and the Electrical Engineering Department for showing us around here today.
Yeah,
it's been very insightful.
Yeah.
Thank you.
Good as gold.